Hey everyone, welcome to episode 2 of The Den, where we discuss topics related to astronomy. And today I'm joined by Jimmy and Richard again. And today we're just going to do a little recap of the major discoveries in astronomy over the course of the past year, given that we're so close to New Year's Eve. And some of the ones that really stand out to me are like the revelation that the moon probably formed only in a couple hours, breaking even in nuclear fusion energy, the finding that meteor or asteroids have nitrogenous bases used in RNA along with like 15 amino acids, and of course India landing on the moon. So any big astronomic discoveries you guys found particularly interesting?
Well,
Well,
um, go ahead.
go ahead, Rich.
No, it's good. It's good. Go on, Jimmy.
No, I was just gonna emphasize, other countries participating in the space race. Um, I think it's, despite the intentions, I think it's important that, space exploration is a shared vision among many different countries on this planet. And so I'd say any spacefaring nation. Dubai has had their eyes on space. India, of course. I think it's a positive to have more eyes looking up and more nations devoting resources to exploring space.
Yeah, I agree with that big time. Because like space colonization, it'll have to be a multinational endeavor. You will need a
Mhm.
lot of cooperation between countries to get it to work.
Mhm.
Right.
I think I'm. I think it's probably my old advanced age and receding hairline, but I'm like more cynical. So my hair goes back further. So does my optimism. So like, I think that. So we're seeing this transition from nation-led space exploration to private enterprise and speculative forecasting in terms of resources. And we just received back to Earth um, returns from Osiris Rex, as a carbonaceous chondrite asteroid. But there's currently a mission out to Vesta, which is probably something close to the core um, of a now destroyed planet during the time of a giant impact about 4 billion years ago. So out there, we have this quintillion dollar worth asteroid just waiting to be mined. Formerly, formerly I worked for, and so yeah, I'm going there. So formerly I worked for NIAC, which is the NASA Innovative Advanced Concepts Program based out of Maryland, and I was really fortunate. That's probably my favorite job so far. One of my favorite jobs of my whole life is I got to see advanced technology proposals, sometimes 20, 30 years on the horizon. And one of them really struck and is getting a lot of momentum, right, is asteroid mining. The question is, how do you get out there? How do you find them? That's been largely answered using spectroscopic surveys of the asteroid belt and determining the orbital uh, dynamic and path and timing of asteroids to look for feasible asteroids to mine. Some of those companies are based here in Colorado. But the next question is, even if you were to get there, whether as a nation or whatnot, you have, of course, issues of near Earth object collision impactors, which are problematic. But beyond that, one of the things that falls out of that exploration is prospecting for in situ resources and also precious metals. There's this push now towards renewable energy, but the question becomes very quickly, I think, it looks really good on paper, and having solar farms sounds fantastic. It's slated probably by 2030s that most of the cars on the road will be electronic, 2050s electronic and self-driven. But the question comes down to, where are these rare earth element metals coming from? There's only a finite
Right.
amount. And
And are they
that also
responsibly resourced?
exactly, exactly. It's kind of a not in my backyard problem, right? Because what's the question? Do we really believe human nature is going to responsibly mine rare earth elements here in the United States when they can go and exploit poor countries for minimal labor or for slave labor and slave wages? Probably not. So by exploring these asteroids and mining these asteroids, whoever gets there and controls those resources is really going to be a dominant factor in terms of this world. And the problem is, I think, is that it may not necessarily be a nation out there that gets to the asteroids and mines them first. It's kind of a Wild West scenario. The first person that gets there in a new gold rush in space is going to have large geopolitical impacts, but now across an entire planet. So I think we're in an exciting time to be alive for space exploration, but also a very precarious time with real implications. And mining an asteroid is not science fiction anymore; it's becoming science fact. So I just wanted to
Right.
throw my vinegar in there.
No, these are great topic points. I think societal responsibility is now a new um it's not new, but it's harder to mask. And I think the social
Mm,
awareness of
mm,
where we're getting resources and how resources are being devoted, and the extent of international cooperation, these questions are now being asked by a much larger
mm,
fraction of the population. And I think the responsibility is upon
mm,
all of us to consider who speaks for Earth, and the direction that we're headed as a species, whose voice
mm.
resonates when those decisions are made. I think these are all critical sort of topic points.
Yeah, yeah. Did you guys hear about Elon Musk? Uh, I went to a talk in the Netherlands here just in November at the European Space Agency, and I brought up Elon Musk. I think relying too much on figureheads or talking heads like Elon Musk about space, and yes, Elon Musk, I'm talking about you,
Mhm.
is unfortunate and unreliable. Elon talks about nuking Mars. That is such an irresponsible doofus response. First of all, he thinks he can make Mars more habitable, but apart from the radiation issue, he hasn't even taken into account the actual water that is available under the Martian crust, which is really not widely accounted for anyway, but it's far below what he thinks would make Mars habitable. So I think people jump on the wagon in terms of Elon and SpaceX. And I'm not saying they don't do innovative stuff, but I would say that they jump on the wagon of NASA. They're good publicists, but not really. I think Elon, and this is only my opinion personally, doesn't have the greatest acumen in terms of science. And I would tell people, and I caution people and your listeners to really think for themselves in the rush towards outer space, because if they want to go to Mars, I just want to remind them that Elon will happily fund you for $250,000 to go to Elon Mars's colony as an indentured servant, because according to Elon, quote, Mars needs pizza too. So
Mars
just
needs pizza.
unfortunately, unfortunately, my decrepitude and crustiness informs me that this is human nature, and there's a lot of would-be Elons out there willing to enslave you for a free trip, one-way trip to Mars to work at subways. Um, so my point being is that I think that yes, initially it'll be a multinational effort, but once we get our feet into the door, the people that are going to make money on other planets or asteroids are not going to be the nations. I think that's a losing proposition, but it's going to be the people that cut hair. It's going to be the people that provide the resources for day-to-day life. It's going to happen, but to think that somehow it might necessarily be this noble endeavor, I differ from a lot of people on that. I hope it's a noble endeavor, but I think it's going to be Pizza Hut in space.
Isn't that kind of like Avatar? Because like the research or the RDA, the Research
Yes,
Development Administration, they control everything
that's correct.
on
That's
Pandora.
right. That's right. That's right. So everybody's gonna go look for an unobtainium, but yeah, there's gonna be people getting sloshed in the local tavern. Absolutely.
I mean, certainly like
Sorry.
stories of like mine workers being oppressed
Yeah,
or brutally
sure,
exploited. They're not without historic precedent.
sure, sure. That's right. We have that here in Colorado too, right? There was the a minor uprising. I forgot what the name was. I wish I remember. God darn it. Yeah, that's right. So the labor disputes, the whole 9 yards. You know what I think is interesting? I want to hear what you guys think. Is that once we get through the exploratory phase and we start actually colonizing the moon and colonizing Mars, what do you think is going to happen to the human race and population society? Do you think we're going to unify, or will we diverge along different evolutionary paths? Would that be inevitable?
I think maybe like
Ooh.
once we get to other solar systems, I think we might start to diverge.
Really?
Or like we
I
might
heard of.
actually, although like terraforming is going to be such a huge endeavor, we might just like identify the conditions present on the planet and then
Hmm.
like genetically engineer the people we're sending
Hmm.
there to live on that planet. So in
Hmm.
that sense, we could diverge.
That's interesting. That's interesting. Jimmy, you had a ooh. What's the ooh, man?
You're saying, are we going to diverge or unify as
Yeah,
we colonize
societal
other
wise.
places?
Yeah, exactly. Like as a
Well,
society,
I
as
think,
organisms.
yeah, I think it's important to consider what will be the impetus that
Mm,
really drives us to explore these other places. Will it be
mm,
human conflict on Earth that drives us?
mm,
And if that's the case, there may already be stratification in place, for
mm,
who actually gets there first, who
mm.
establishes a territory and who claims resources.
Right,
And, if we're not careful, we could just repeat the stratification that we see here on Earth. And it's
right,
very possible it could be heightened in a sense.
right,
I think
right.
about, I've been watching The Expanse, which is a, show on Amazon Prime. And, in this vision of future exploration of space, they're Earthers and asteroid
Mm,
belters and Martians, and all three are competing for
mm.
resources and power essentially. And so
Right.
the
Yeah,
intentionality cannot be understated. Like
yeah.
that will determine like future evolution of our species.
Mm.
Well, I kind of have like
Wow.
a what I call going up the tree model. It's like I think space exploration might start to bring us like earthly society together as like the as you go up from underground, the roots kind of converge at the trunk.
Mm,
Then we'll be united for a bit, but then once we start to spread out into space, though, we'll start to like branch out. But will these
mm,
branches exist in harmony or will they bump up against each other? I don't know. But
mm,
I think something that might mitigate any kind of power
mm,
struggles is that um, wherever we send people, their societies
mm,
and possibly even their biology will be
mm,
tailor-made for that specific environment. So
mm,
there'd be no need to bump up against each other. And this is what we do
mm.
see in like the natural world a lot. Like there's like fights between big predators for existence are really rare because it's just not advantageous to fight each other when you have enough resources.
I hadn't thought of that. That's interesting. That's interesting. For myself, I feel like it'd be a mix of like 2001 and Gattaca, like for like a movie reference.
Oh
You
yeah,
see
I remember.
Gattaca?
Yeah, I saw Gattaca.
Holy smokes! Right? What was it? What was it? They want to get to Elysium or something like that. It was a cool name. Was it Elysium?
Yeah,
That's what I would name it. Yeah, it's Elysium, right? Dude, that is like so human. I think, right? Like
right, right.
2001, the two monkeys bunk each other on the head with a thigh bone. Next thing you know, they're
Right.
floating in space. But then after that, like Gattaca comes along, and you have to be genetically perfect to like get to Elysium. Otherwise, you're just a slave laborer. I think
Yeah,
in reality, those appeal to me because they're like so accurate to like I think how I see humans. But I
yeah,
also think there's other limitations because like yeah, I don't know. Just I'm just not as optimistic. I just think that people are people, and I hope that they rise to the occasion. It would
yeah,
be interesting for your listeners to give you some of their own thoughts and feedback. Maybe we could talk and respond to some of their responses, and they could let their friends know about your podcast. We could have a conversation with them a little bit.
yeah.
I
Maybe
would
I could
like to
do
hear
like a Q&A thing sometime.
what's that?
Q&A thing.
That would be awesome. That would be awesome.
Yeah.
That'd be
Also,
awesome.
on the issue of international cooperation, like I wonder if like because India succeeded, but I wonder if like the failure of Russia to actually land a probe on the moon because it like crashed had something to do with being like cut off from a lot of resources. They couldn't maybe get the software they needed, but I don't know if they really disclosed
Um,
the details on that, or could this just be a freak
um,
event?
Yeah, I think a lot of that is not been publicly released.
yeah,
Uh,
right.
but yeah, generally the
Yeah,
mistakes are less publicized.
yeah, 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 yeah. Russia's definitely sliding backwards, right? They're getting back into the whole era of Pravda, which ironically means truth, I think. So not so much, you know. But
Hmm.
it's interesting because other nations and non-state players have really realized that space is this high-profile endeavor, and it's not easy. I mean, whether people can get there or not, it's just not easy. Because India also failed to land, I think, as well. It was on Mars, right?
Mhm.
Was it on
Yeah,
Mars? No, it was India. It
But
was
they
on the
did have a
moon.
successful. Yeah.
but yeah, they landed on the moon successfully, but I think they failed on Mars.
Yeah, and Mars is hard. Mars is a hard target anyway.
Yeah, at least they don't have to worry about a mess up because
Right.
somebody
But
forgot to feed the
prestige goes
units.
behind it. And was a Mars Polar
Right.
Explorer slammed into it because
Yeah,
they're using U.S. units.
Right.
Jeez, that poor
Kilometers
intern.
instead of miles.
NASA's need to check its Pathways intern program a little harder.
Yeah.
yeah,
So, but yeah, one thing I am happy that the United States is taking back power for the next push in space exploration, and I'm really, really happy that Artemis is going through because too often good ideas at NASA come to are laid in front of
Right.
NASA by current administration, and then new election cycles
Right.
come along, and the next president's like, "Well, that's not my baby, so I'm going to rip that out
Priority.
from the roof."
Right.
Yeah, and it gets to like TR3, it's TRL like 6 or 7, right? Stuff's advancing, the
Right.
mission architecture's put in place, budget's put in place, and then there's just like a restructuring, and everyone gets laid off. There was a lot of grousing at NASA over the Constellation mission. And the Constellation mission, everyone was jazzed to go, and then like the next administration just yanked it, and so
Right.
NASA has suffered, unfortunately, I think a lot of internal hemorrhaging in terms of its sense of worth and direction since the Apollo mission. Because when you look at NASA and you live inside of NASA full time, you get a real sense that people are proud of Apollo, and there's a real yearning to
Right.
go back to the glory days or recreate the glory days. And so I'm really happy to
Right.
see people embracing Artemis. Artemis gets criticized that it's Apollo on steroids, and that's true. It is in some ways, but it's also a brand new structure, it's new technology. And guess what?
Right.
It's getting us there. And so let's all get behind. I think let's all get behind Artemis, not just as a nation of the U.S., but let's get behind it as a world. Let's push forward. Let's be
Right.
optimistic. Prove me wrong. I'm
Right.
I'm an old man now, and I realize it. Right, like before this podcast happened, man, I had to get on there and I had to get like Zoom face, and I was like, holy crud. When I went to NASA, I used to laugh. I was like, wait a minute. I'm innovative and I'm dynamic. What's the story with all these old bald men with white hair and glasses? As I pushed my glasses up with my middle finger, I was like, wait a minute. Oh, I get the joke. So your listeners are lucky that this is on audio. Let's put it to you like that. But it's the young people, it's the next generation, and Artemis serves this fantastic purpose. I think it has real potential to really ignite fire and passion in people's spirit, which is really needed for space exploration, right? It's not just technical acumen, but it's something that the two of you and Mitch has, who's our other buddy in the Wolf Pack. Like everyone in the Wolf Pack has this burning passion inside of them, not just as scientists, but as people. Um, and I think that it's that human spirit that really drives us towards space exploration. And on that note, I want to pass it to Jimmy. If you're comfortable, Jimmy, talking about some of the passion about space, like like the importance of space and science and stuff. And I'm just going to step back.
Well, I think you're offering a great perspective and narrative I think that space exploration, right? It comes from a natural curiosity that many of us have as kids. Looking up, at astronomy. I think from kids to adults to senior folks, there's this awe from something greater than ourselves, and somehow like a part of ourselves within ourselves. It's macroscopic and microscopic part of us. And I think that, there's that craving for return, at least, for some of us, driven by discovery, right? Like
Mhm.
understanding new terrain and, new types of planetary existence. Could there be species that have evolved, right? Like, are there other environments we're not aware of that are conducive to life? These are some of the key driving questions that I think are fueling, the next generation, even the current generation of scientists who have, not since their childhood seen, a rocket with humans, land
Mhm.
on another planet or another celestial body. And so, yeah, I do think there's, we're now approaching the era where the
Mhm.
technology and the vision can couple. And so with
Yeah.
reusable rockets or international partnership, we're at a stage where it's possible, and that's a very exciting frontier to be on. But the key is it's going to require that collaborative effort. If we're competing with other humans just to claim that we have beaten them, that
Mhm.
if the motives are corrupt, the end will be corrupt too. And so I think it's
Mhm.
important for us to understand why we choose to explore before we do so.
Yeah. And
Mhm.
here's something
And
that's
yeah,
oh, um,
no, good.
yeah. One of my pet peeves is when people like ask, well, what's the economic benefit of space exploration? But it's like
Mhm.
we aren't cogs in this in an economic machine. Just us being interested in it
Right,
adds value to it. It adds a reason to do it.
Mhm.
right,
Mhm.
Not there
But
aren't
the
that.
thing. Go
I mean,
ahead.
there's
Sorry.
certainly economic benefits that could be had in the near
Yep.
future, but I
Yep.
don't like I don't like it when it just gets broken down to what are the economic benefits of like colonizing another star system or whatever. Like we're more than
Mm.
like we don't exist for the economy. The
right,
economy exists for us.
Mm. Mm.
right.
Yep.
Well, I think a lot of magic is also lost when the reason you're doing something is only, if it's financial, right? If there's a
Mhm.
payoff, then the
Mm.
exploration itself is simply a vehicle to get there. And the wonder of it is that exploration. It's that journey through space that allows us to appreciate in a broader context what we
Mm.
are. Organic life forms on a rock,
That's right.
like that reality. And we're the only life forms we're aware of. And if we had sort of the presence to understand that, I think that could be a big unifier, of our species. And so that's why I say, getting caught in what is the financial gain, what's the political gain.
Mhm.
As long as space exploration is a tool, it will never be the focus.
Mhm. Mhm.
Inherently, like the exploration itself.
Mm. Mm.
But
I think that the one of the challenges of academics is we tend to live in silos, and for that reason, offices like the Office of Public Affairs and Relations at NASA does a really good job because they hire young talent that's able to get out there and communicate the relevance of science, the relevance of NASA to the lay community and to other scientists. And that one of the very marked statistics in terms of economic relevance of NASA is is a surprise to a lot of people, including myself initially, is that the return on investment regarding direct return on investment, not just ripple effects, but direct investment in NASA For every dollar invested in NASA, returns economically $8 to the public. So to the nation,
Wow.
NASA is an investment. It is not a detriment. It's an 800% return across the system. This, of course, averages out losses as well. But surprisingly,
Right.
guys, guess what program? And again, this was unbiased. The program that has one of the largest returns on investment in NASA is NIAC. NIAC is a small program. It's funded on the order of several $1,000,000. I'm not quite sure what the budget is now. I think it might be somewhere around
Right.
20 million. It might be more, but it's a relatively small program. And listeners, go to NIAC, apply. You do not need to be a NASA scientist to work there. You don't need to be uh, with our friends at Boeing, Northrop, or Martin Marietta, Ball, any of the big aerospace big hitters. You could work literally out of your garage as a U.S. citizen, apply for NIAC funding, and start your own aerospace company next year. Go to NIAC. Go to NASA. Look for NIAC. I swear to you, I will champion these people and I will drop on a sword for these people. They're great. And no, I'm not being paid to say that. I am not being paid to say that. In fact, I was brought in as an intern at NIAC some years ago as a program analyst to analyze their performance, um, and it was kind of an internal audit. It was agnostic, and it turns out that NIAC has a return of hold on your pants an order of magnitude greater than NASA in general. It has a return on investment for approximately 8,000% return on investment on a dollar. I swear to you, 8,000% return on investment. I know
Wow.
it's bonkers. It's bonkers. And the return on investment is that I had to explore it. Do you know what other industry has that kind of return on investment?
What?
No?
No.
Hollywood blockbusters.
Whoa.
Dude,
Wow.
Hollywood blockbusters, right? For every stinker put out by Hollywood like Cats, sorry, they put out they're gonna put out a blockbuster that's gonna carry them through. Like those guys in Hollywood, they know what's what, right? They're sitting in the boardroom, right? As Bill Burr says, like eating fried bald eagle and like dominating the world. And they're over there like thinking, okay, well, how are we gonna make money? Okay. Hollywood's not out there to educate you. Hollywood's there for the buck and for the dollar. They know that there are certain percentage of movies they're gonna bomb, but some movies are gonna carry them through for the industry that are gonna be blockbusters, right? There's gonna be a Harry Potter out there somewhere,
Mhm.
whatever. And curiously, some of the largest blockbusters is science fiction. Is that really a coincidence that the
No.
largest return on investments are the freaking programs that are most science fiction coming out of NASA? Absolutely not.
Wow.
You just said it, Patrick. No. In fact, the NIAC, one of the NIAC, I don't know what you call it. The NIAC, the saying for NIAC is NIAC science fiction to science fact, right? This is the DARPA of NASA. Every listener that's a U.S. citizen can participate in NIAC. Tell them Richard Archer sent you, and go to NIAC. Put in your application because one of you out there, I swear to you, you're a Madame Curie or you're an Einstein, and we believe in you. You put in your application and help us push you through because there's all sorts of bonker programs out there. There's stuff of like fusion propulsion, asteroid mining, how to turn an asteroid into a space colony that's self-propelled, for God's sake. I mean, it's like next level stuff, right? Like biomimicry and spider exploration of subterranean lava tubes. That's the one I wish that I had put in, right? That's like Velcro of like, ugh, I should have thought of it first and submitted a grant. But I didn't know NIAC existed at the time and I didn't do it. NIAC's out there, it's waiting for you. Be part of the dialogue, be part of our progress, be part of our exploration, be part of your future, be part of humanity's future. Go to NIAC, apply. I don't care if you're at a university. I don't care if you finished college. I don't care if you did or didn't. One of the guys that got okay, I'm almost done. Sorry. Ugh, I love NIAC. Sorry. One of the guys that won a NIAC grant, I think it was like last year or 2 years ago. This guy does crazy cool stuff. I'll let you search for him. He got a NIAC grant while he was in community college as a non-traditional student, and he blew it out of the water. So you're out there. I know you're there. I've seen you. I've met you before. We've shaken hands. Call your cousin and get them to apply too. You can be part of this future that we're talking about today, and you can help set us on the right direction. Go apply to NIAC. All of it's there. I'll send I'll send Patrick the information about NIAC. Patrick, are you cool with like posting that for everyone?
Sure thing.
All right, I'm gonna send that uh, to Patrick, and I'm just joking about saying Richard sent you, but if you want to do that, tell Kathy I said hi. Kathy.
Take them up,
So
folks.
so hit him up. First year
Sure.
is 9 months. If you win, it's a 9 month grant for I think it's how much is it? 120,000 just to do an initial study of feasibility, and then like the next year, something like half. I think it's gone up. It's 500,000 for 2 years, and then it's a $2 million grant for that to progress you through. And NASA will capture you and your technology, and as it moves forward, will push you through, and you'll maintain the IP and all of the legal um, power over your invention. It won't be stolen because guess who your IP partner is? It's NASA. So it will nurture you through the Science Technology Mission Directorate and push you through and bring you into the NASA missions. And again, these are on the 20-year horizons, right? Beyond just spinning around a low Earth orbit. I mean, come on, let's get off of going around the apple. Let's go out into space now.
Yeah. Oh,
and
it's
and yeah, okay, but astrobiology. Sorry,
like I was just saying, like
clearly I'm
thinking about like
dorking.
the future of like
I'm dorking
the
out.
future of, like nuclear fusion, but like
Yeah,
now that we've like broken even, do you think that's going to become a thing in the near future? Now that like we
yeah,
can get more energy out of a fusion reaction than we can
oh
than
yeah.
we put into it? Like how do you think that's going to take
Well,
off in the next few years or decade or so?
yeah. I'm not a physicist. I'm a biogeochemist. So I'm gonna punt to Jimmy. To Jimmy.
I'm going to defer on this one. I feel like Patrick, you probably have more insight on this, and I can follow up. But you
Oh,
know, yeah, go ahead.
well, without space exploration, I think I'm kind of skeptical because I don't think it was like a neutronic fusion. So I don't think until we actually start mining like the moon or the gas giants for helium-3, where we
Mm,
can fuse it with
mm,
deuterium and get a neutronic fusion, that we're
mm,
really going to be getting like huge fusion powered plants because okay, you can
mm,
break even, but if you're generating too many neutrons,
mm,
you can't run the reactor very fast without actually
mm,
destroying the reactor. So I think
mm,
that's going to be the biggest hurdle. I think that kind of comes back to the importance of cooperation in terms of
mm,
exploring space and even like getting resources out of space if we're going to get this a fusion
mm.
economy up and running.
Well, I don't. I think it's yeah. Well, I think it's like what you just said is behind the current space race to the moon, right? So there's this current endeavor to map the moon and look for helium-3 and also for just hydrogen emission as well for water and so forth. One of the problems with the moon and prospecting the moon is that recently there's been work using Sophia, the airborne observatory from NASA, looking at the moon, and they thought that they were able to find and detect water outside of the polar regions of the moon, which is pretty tough, right? Like initially, it's kind of incredulous to think that because the moon goes through those large variations in temperature and also the higher heat of formation during the impact of Theia would have been very difficult for the moon to retain a lot of water. It's thought because it's considered a high energy impact, and that the where the water might have accumulated from the moon is thought to have perhaps been accumulated over billions of years by a micrometeorite impact of water-rich uh, uh, asteroidal material. But once you get into sunlit areas, it might be possible that they're confounding a water signal of water ice with a phyllosilicate, which is water bound inside of, well, hydroxyls actually, more accurately, bound inside of phyllosilicate or clay material. And that's not easily extractable at all. So once it goes in there, that works as a water sink. So what portion of the moon is actually habitable and available to be mined for water necessary, not just for colonization, but for rocket fuel generation, might be quite limited. The flip side of that question, though, is that there's some evidence that, in fact, there might be, in fact, water ice and not phyllosilicate signals in the spectral surveys. And recently, there was a paper written out of LASP, out of Colorado CU Boulder, using small satellites to survey the entire moon for 2 years and map the surface of the moon and look for those ice signals, which is a doublet in terms of the
Wow.
signature. What they're seeing was only like a single spike, which could be in the a phyllosilicate or water. So the small sat is under $1 million, and it can map both on and then give a high resolution mapping of actual water ice and differentiate between water ice and phyllosilicate hydroxyls. So that program is called Lunatics. If people want to look that up, that's in the LPSC abstracts.
Gotta love the naming
Um,
conventions.
Lunatics. Yeah. So um, it's a lunar concentration ice, a lunar concentration technical ice survey, something like that. Lunatics. Um, what was my point? But if they do find water ice outside of the polar regions, well, then you open up an entirely new world to planetary colonization. And you're like, okay, well, there's a lot more water here than I thought. But it also would have huge
Right.
implications about um, the creation of the Earth and the Moon, because that would imply that the collision was not such a high energy event, and that water had been conserved, where before it was thought to have actually been very high energy, desiccating the moon effectively. So, but yeah, so that rush for in situ resources, man, it's going to be the next level thing. We have to
Yeah.
get out there and get ahead of everybody else, big time.
Yeah, but I think like going back to like the nuclear fusion thing, I think like it's kind of hard to say at this point if it's just going to continue advancing kind of like the slow pace it has been, and it might take maybe another few decades before we even get like a working prototype nuclear reactor. But I do
Mm,
think that now we've broken even though,
mm,
there's going to be a lot more investment into it that can like
mm.
really speed up the development.
Do you feel like, though, opening it up to private investors might be problematic? Because then you have this whole issue of like oligarchy control.
Well, it's not necessarily private
Mm,
investors, government entities can also invest in things.
Okay.
I still think like government bodies would be more eager to invest in nuclear fusion now that we have broken even.
Well, Jimmy, do you think that's going to be? Do you think that's going to be like a? I guess the same old question, like unifying or kind of despotic?
well, I like to follow the trajectories that have existed before, and
Yeah.
I hope for the best, but I think it's wise
Yeah.
to prepare, for the worst.
Yeah.
But it is
Yeah.
fast just to think of how far we've come from just understanding what nuclear fission is, right, in the solar
Right.
context or in stellar formation to already where we are today.
Yeah.
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 It's fascinating.
Yeah, I actually
Yeah.
made a video on this topic. It was like, why your body's more effective or more efficient than the sun at producing energy. Because if you actually look at the total mass of the sun, divide the power output of the
Right.
sun by the mass, you'll find that our own body tissues are 1,500 times more efficient at producing energy than the
That's
whole
crazy.
material of the
That's
sun.
crazy.
Is that right?
Yeah. And it's like
I,
that kind of does damper one's hopes about a future powered by nuclear fusion because yeah, they often tell you that you need the astronomically high temperatures and pressures in the core of a star to get nuclear fusion going. But what they don't tell you is that even they suck at it.
hmm.
Right.
I didn't know that.
Yeah.
So maybe we should just get hamsters and put hamsters in a wheel and make them run. Lunar hamsters, just whip them all day. I,
Yeah, but
I, I
like,
thought I didn't know the stars were so inefficient. I did not know that at all. That's wild.
yeah, I think it's just counterintuitive because you think like, oh, well, we're like our body temperature is what 37 degrees Celsius, and the
Right.
core
Right.
of the sun's millions and millions and millions of degrees Celsius, but thing is, like, there's only like each 65 million tons of core material only has a square meter on the surface of the sun to dissipate all that heat that's generated. So
Right, right.
Hmm. Man, I'm out of my depth with that. I did not know that.
yeah, it's just one
That's
of those
pretty
super
cool.
counterintuitive things. And it just
Right.
shows how, like, our mind is adapted for what Richard Dawkins calls Middle Earth, just
Hmm.
at the
Hmm.
scale we're dealing with. It's not meant to, it hasn't evolved to cope with the very big or the very small, and that's why it
Right,
seems to get
right.
lost in these things.
Right. Like when
Hey,
you look
Jimmy.
at the Planck length versus the
Mhm.
like
Yes.
entire
Exactly.
size of the universe, we're right in between that.
Exactly. Dude, exactly. You read my mind. Jimmy, I was just gonna ask you about that, man. Like you just answered it. No further
Yeah, I mean
questions.
it's fascinating. Yeah, it's kind of fascinating that
Yeah.
we exist in that sweet spot that we do.
So Jimmy, it's like it's crazy then like what we consider ordinary is just a confluence of being on that sweet spot, right?
Exactly, exactly.
Talking about sweet spots and habitability, Jimmy, can you talk to us a little bit about like stellar recycling and the galactic habitable zone?
Oh, so in terms of distance from the center of the galaxy, or in what
Yeah, I,
context?
yeah, exactly. Like, is there
Mhm.
because galactic stuff isn't my specialty. Um, and for your listeners, like on the pecking order, Jimmy's far above me. I'm a terrestrial solar system. I don't even have the huevos to like explore gas giants. And he's out there like at the galactic cosmological scale. Okay, he's like
Right.
lotus flower astronomy, and I'm like, hey, look at this dirt. So very very
Yeah, no,
different
it's
scale. I'm like,
fascinating.
that's big dirt.
There's surprisingly there have not been a lot of recent studies on sort of galactic habitability zones, and that's just
Interesting.
because we're still at the forefront of like exoplanets and exohabitability.
Yeah.
That's we're talking 2 to 3 decades, if
Wow.
that, not even that,
Yeah.
maybe 1 to 2 decades. So it's a nascent field. It's really um, beginning to be understood. And,
Mm.
you also have to understand that galactic processes are like if you have an active galaxy, right? Or if you have,
Yeah.
winds that are emanating from the center of a galaxy, we're still trying to constrain sort
Mm.
of what the spatial extent of that is, what degree of
Mm.
ionization, photoionization, harmful X-rays and gamma rays, we're still
Right.
trying to understand the scope of that.
Mm.
And so those questions really haven't been answered. But what I can
Mm.
tell you is, if you're at the center of a galaxy, and there's in most galaxies we agree that there's a supermassive black hole, and for some of those
Okay.
galaxies, right, that are active, they can shoot out jets, they can consume matter nearby, form what's called an accretion disk, and those jets are very powerful radio jets
Wow.
that are produced through synchrotron radiation, right? And so you can have these highly energetic fields that essentially emanate from a galaxy, and
Mm.
that can extend several kiloparsecs, which is we're talking thousands of light years from the center of that galaxy, and so it's
Wow.
really a matter of directionality. And
Okay.
obviously, if you're a young planet that is starting to form life, and you have
Mm.
intense electromagnetic radiation, that can inhibit sort of biological processes from ever taking off. And so in that context, you know galactic habitability is very
Mm.
much a concern.
Mm.
But the field, I'd say, for now, we're just trying to find Earth analogs, right? Or, planets that have atmospheres like ours, because those are the tracers we know for life. And so I think
Mm.
the question of galactic habitability is one that we're not there yet. but it is an inevitability, as we get more, deep into that rabbit hole.
Yeah.
Jimmy, I don't know much about the field. So the jets are perpendicular to the plane of the active uh, galactic.
That's right. So you can think of so for an active galaxy, think of like a sink drain. So at the center of the galaxy, you have matter that's swirling around that gravitational field. And as you have these electrically charged particles orbiting at high velocities, you create perpendicular magnetic fields. And
Hmm,
that's you write Maxwell's equations. That's where you get your perpendicular um, field of your perpendicular jets, which are
hmm,
simply particles following magnetic field lines. And
hmm,
you can have these jets. You can also have winds. You can
hmm,
have these regions known as broad line and narrow line regions, where
hmm.
essentially you have clouds that are moving at very fast velocities. Um, and so all of these can influence nearby stars, and that trickles down to nearby planets near a
Sure,
galactic center.
sure, sure. So does the active center, can it be turned on and off depending on the influx of material, or is it just like a process
That's it.
for early
It
information?
just depends how much fuel is available.
Is that right? Does it clear an
That's right.
area of material, or does it just like voraciously consume?
Yeah, that's right. It clears out
That's neat.
dense, cool matter, right? It clears it
Okay.
out, heats it up. And so it
That's
also could reduce star formation, which is another thing that limits the ability for habitability in a galaxy.
as you're talking, I'm having this like picture in my head of just being this little life form in an egg, just waking up and be like, oh, it's gonna be a good day. Oh, wait a minute, someone's turning on the microwave. Poof.
Well,
I know that's just
I
silly.
think actually, UV light and cosmic rays might not always have been a hindrance to early life. I think there are actually some examples where we could say it could have actually been helpful.
Wow.
Because like the ribose in our DNA and RNA uses a specific isomer, the D isomer, and what people have found is like UV light will actually selectively break down the other L
Mm,
isomer that when you incorporate it into DNA or when you try to, it'll like disrupt like replication, all that stuff. So it could have broken down like the disadvantageous isomer of it, and it might have actually facilitated the production of amino acids on the prebiotic Earth because high energy particles from like the flaring sun back when it was young,
mm,
temperamental, hormonal, whatever, um,
mm,
could have actually helped like partially split apart nitrogen atoms or nitrogen molecules in the
mm, mm.
atmosphere so
To
they could
make
actually be fed into like Haber-Bosch type reactions in hydrothermal
mm,
systems to produce ammonia, and then Strecker reactions could link them with alpha keto acids to produce amino acids.
that's
So
crazy.
yeah, so radiation may not have been as the it was probably like a mixed bag for the beginning of life, shall we say. I think until you get to the point of photosynthesis, then yeah, it's going to become a bigger and bigger problem.
Mm,
But it might have actually
mm.
helped life get started.
I feel like all these talks, like as an astrobiologist, all these talks like circle back to this main theme that like eukaryotes are sissies.
Yeah, it's like people say,
Prokaryotes are where it's at, right? Like,
yeah, it's like people say, oh, for just how many billion years, like 2, 3 billion years, whatever, it was just simple single cell life forms. It's like, dude, have
mm,
you any idea how versatile these organisms
right,
are? Like we can what
right,
we can just take organic carbon and then oxidize it. They can do a whole slew of things. They can
right,
take all kinds of electron donors and acceptors. They can
right.
take carbon from all kinds of sources, maybe even produce their own. Sometimes you have
Yeah,
weird mixes where they take organic carbon from the
mm,
environment to actually be assimilated into their own biomass while using light for energy.
yeah.
Hmm.
It's crazy.
But it's interesting because like there's a continuity of cosmological events that help life come together, as Jimmy said, sort of this like sweet spot, right? Because you have these active galactic nuclei, but in some ways it seems to me, and Jimmy, I'm just talking as a layperson, kind of from an ignorant perspective, but listening to you, I still hear this continuity of events that both destroy and facilitate the possibility of life, including black holes. Because without a framework of black holes, it seems like the complexity of nuclear synthesis and subsequent chemical synthesis would be effectively impossible. So, right, so the same thing that could wipe us out initially is also sort of this framework that we hang our existence on.
Right, right.
And
Well, I do think, as long as you have, right, like, stellar fusion also, right, creates the fundamental ingredients, but certainly the dynamics of the galaxy, influence the arrangement of all the matter within it. So it is the parent that is, dictating, the
Right.
motion of objects in its influence.
yeah,
Right.
I think also a pretty interesting discovery when we're talking about like how life could begin or how similar it would be on other planets is just the realization that like we do find like all 15 amino acids and like nitrogenous bases like uracil on meteorites, and that really tells me that abiotic synthesis reactions just tend to produce these products, and these were ultimately like why uh, they were used by the first organisms. And the biocatalysts we utilize, like enzymes and probably before then ribozymes or some weird mix of the two, probably just evolved around these reaction networks that produce these molecules.
Hmm.
Right.
Can you can you tell me? I'm a little bit ignorant. Can you? Well, I'm all ignorant about uracil. Can you tell us some of the significance of uracil and why that's important?
Oh, because that's one of the nuclear bases or the nitrogenous bases that's in RNA. Like because they're four base pairs in DNA. They're like adenine, guanine, cytosine, and thymine. Well, in RNA, instead of thymine, they have uracil.
Okay. And so so you buy into RNA life, the idea of the RNA world,
I don't buy
preceding
into the
DNA.
idea of the RNA world in that I think that um, RNA basically catalyzed all the reactions in the first organisms. I think it was probably tied to their molecular biology, i.e., reproducing itself, and possibly phosphorylating simple organic molecules to be fed into these synthesis pathways. But I think a lot of these early reactions were probably catalyzed by inorganic fact or inorganic materials like divalent metal ions and iron sulfur nanocrystals. And also, I think something that's really been overlooked in the field of origin of life is B vitamins because they can be part of like an autocatalytic self-replicating network because they synthesize or they catalyze the synthesis of one another from simple organic precursors. So I think RNA probably just started by replicating itself and only had like a minor role in feeding simple organic molecules into these metabolic pathways. And I think gradually that role expanded over time, but as they expanded, they started including more and more peptide cofactors until these ribozymes became enzymes. So I don't buy the RNA world hypothesis, and I think that RNA catalyzed all the reactions in the first organisms. I think as biocatalysts facilitated more and more of these reactions, uh, the biocatalysts themselves increasingly resembled enzymes.
Hmm. Hmm. I don't think that it's a coincidence that the what you're saying regarding I do think there's this sort of possibility of this biotic abiotic jump from relatively simple aqueous chemistry, hydrothermal systems. And I always thought it was fascinating, right, that we have these like siderophilic um, coenzymes in our cellular pathways to incorporate iron, and then other enzymes that incorporate copper and alkali metals, right? So we find these commonly in hydrothermal systems, and to me, it's just fascinating that life found a way to incorporate potential metallic um, toxins as a needed compound.
Yeah,
But it gives me a lot of like optimism that life is probably ubiquitous out there in the cosmos. Truthfully,
yeah. Although
between
it can
the
make,
Right.
I was gonna say, it can make panspermia kind of hard to verify, though. If we find life on
mm,
Mars and it uses like the same amino acids or
mm,
the same nitrogenous bases,
yeah,
now we have a reason to
yeah,
think that it would have evolved that convergently.
yeah,
So genetic
yeah,
code, bit of a gray area, but I think the only way we can say for sure that panspermia occurred is if we can
mm,
find like homologous enzymes to ones we
mm,
find on Earth.
mm. Yep. Well, I mean, but it's curious, right? So, like now we're actually getting this asteroid material back from the asteroid system coming to Earth. So we just got the material, the Cyrus Rex material. They thought they'd capture just a few grams, but now they have so much they can't even open the canister.
Mhm.
So just what was on top of the
Wow.
canister was more than they expected for the entire mission. And when they look at it now, they're super excited because they find in fact that it's carbon rich, water rich, amino acid rich. It's I heard that it smells a little from friends at JSC that smells a little bit like tar, which is
Mhm.
crazy.
Oh
Like that's
no.
nuts,
Yeah,
right? So
what's tar made out of? Like all these weird
yeah,
organic
it's
molecules.
sulfurous carbon compounds. Like sulfurous carbon compounds. He said it smells like matches and tar. And that's exciting, right? So that tells you right away that it's got like complex compounds in it, um, alkenes, alkanes, all sorts of neat stuff. Amino acids, it's water rich. But I took a course at CU Boulder in my last semester there on the Oort cloud, and one of the cool things we're talking about is that by the time you get out to the Oort cloud, it's really bumping up against other Oort clouds, and so you could have promiscuous exchange of material between systems, especially when you consider, for example, like suns can the star can go through the galaxy, not bump into any other stars. However, sorry, the gravitational field of neighboring stars allow Oort cloud mixing of material, and so there is a percentage of our own Oort cloud which is thought to be exogenous, which is not native
All
to
right.
our own particular star. This also to me is exciting because then on galactic time scales, um, relevant, I think, to Jimmy's work, that's a lot of mixing of material and exchange of material, of primordial material between stars and over, I think, cosmological time scales. That's a lot of time to exchange material for life to potentially evolve in a lot of nurseries.
Right.
Yeah. Oh, but like going back to like the moon and water, do you think the if it actually did form in hours, as like that
Hmm.
new model suggests, do you think there probably would be a lot more water because there wouldn't have been time for it to like evaporate off the molten rocks that ultimately coalesced to form the moon?
Can you send me that paper? I haven't read the paper that suggested it's formed in hours.
Mhm.
I
Yeah, I haven't either.
haven't read that paper, to be honest. The last one I read was a paper by Sarah Stewart. She talked about how Theia was an oblique impact of like 45-degree impact, ripped off the crust in the mantle, but didn't extract the core. Um, Reliquefied Earth, which I buy that. I also buy that it's mostly mantle material that is ejected, but that it formed a synesthesia, so it formed like a torus. No, not synesthesia, right? That's when you sneeze when you look at the sun. Synestia. Sorry. So synestia, which is this. Sorry, I didn't say I was brilliant. Fucking dummy. Synesthesia is like when, for those that don't know, it's like when your senses mix and like you see sounds and you sneeze. Honest to God, when you sneeze, look at the sun. So yeah, I don't think he sneezed looking at the sun when they hit Earth. It was synestia, which is a torus, right? Like a donut. So a torus is the inner region rotating around the liquefied molten Earth. So there's a model that suggests that the moon might have formed in this torus. Other models suggest that it was more of sort of like Saturn-like rings. But I think there's probably a continuation between a I'm just going to stop using that word. I'm just going to drop that word now. The donut. I'm not going to embarrass myself anymore. Okay. Between the donut and the sort of Saturn-like ring arrangement, because um, Thea, I have every reason to believe Thea, of course, happened. Um, I have a little 8-year-old boy who I adore, and he's raised in my household, both in the dominant culture and as well as in Tewa indigenous culture, which I'm part of. And so he has questions about why is Christmas important, what is Halloween, and so forth. And I tell him, I said, well, it has to do with the orbital dynamics of the uh, of the Earth, and that is a reflection of gravitation and evolution of the solar system. And the seasonal rotation of the Earth is primarily a function of um, the obliquity of our planet, which is caused by
Right.
Thea's impact. And so I explain all this stuff to him, and he experiences it as a little boy, as the beautiful 4 seasons we enjoy, the current holiday season we're going through, and Santa Claus. So it brings it down to like the individual human scale, right? Which is also nuts that it's like because of some impact 4 billion years ago, and he gets presents, right? He gets Legos because we hit by a Mars-sized planet, so he thinks that's sweet. So then but what was the question? Sorry, what was the question? I know I'm on the right track. I got lost. I talked about Legos. Now I'm gone. Bring me on track. Something about I don't know if it was formed in hours. Seems doubtful because of the height of the impact. Probably would have desiccated the moon. That's my holy grail pass. Probably not. The moon would have been a lot drier, more desiccated. It might have been a low impact, low energy smash up, but even low impact, right? Two planets hitting each other, it's going to be a mess. And I think that the water on the moon that has been found in ISRU surveys thus far is starting to slide my opinion that it might have been a lower energy impact than initially thought. But I think that it's still out there for refinement and further models, right? We can't get in a time machine, but we certainly can use isotopes such as hydrogen and rare earth elements to try and approach this topic. And we're going to get a lot of those answers when we go back to the moon. It's going to be exciting to find out. I just don't know. But the moon's super important from an astrobiological perspective. But yes, Thea happened. Sorry, guys. It happened. My son went back and bragged that he learned about Thea, as was promptly put down by his colleagues and fellow academics in preschool, who said that that's not true and that the Earth was formed in 6 days. Yeah, 6,000 years ago. I think, which
Yeah,
was
so I remember
really be
like
a surprise.
when I first learned about it in high school, I remember like the planet being called Orpheus instead of Theia.
I mean, who knows? They're just everyone's operatic. Everyone's looking for the new name drop, right? I don't. I didn't know about Orpheus. It sounds pretty good. It sounds pretty good. Um, yeah, it sounds like a good name as any. I'm not attached to Thea, but I think it's curious that these orbital dynamics of early solar system creation and also the galactic creation like affects our daily life, right? That's pretty sweet. And it impacts us in ways that we
Right.
don't give much thought to, but maybe we should.
Yeah. Speaking of which, for like a future podcast episode, we're planning on talking about like how Jimmy and Rich's cultural backgrounds really got them into astronomy
Mm.
and similar fields. You guys want to throw a little teaser?
Well,
Jimmy,
I'd
you want to
say
go?
not so much for me. It wasn't how the cultural aspects got me into it, but I can definitely talk about the how do you bridge your own culture with the
Mm.
academic one when they are not aligned.
Mm. Yeah, yeah. Jimmy, do you want to talk about sort of like your interest in education?
I think let's leave it for the audience to
Okay,
let's have
fair.
them tune in to get the full
Yeah.
details. But obviously, I think through education, the universe I think is fundamentally all of
Mm,
ours, and
mm,
I don't think any one group has agency over our universe.
mm, mm. Yeah, that's great. That's good. So for myself, I'm Tewa. I'm from northern New Mexico. My family is indigenous, native. Um, I thought I was getting away from kind of the cosmological stuff of my birth, of relating myself to the seasons and seasonal cycles and so forth. And ironically, our one of our ancient pueblos is under the site of the now um, present Los Alamos Labs. It was actually one of our ancient Puebloan sites a long time ago. And my life kind of, I thought I'd get really far, but I was just sort of spiraling in the same circles because I worked for NASA, I worked for LASP, both of which were derived originally from the Department of Defense and were offshoots of Los Alamos to some extent. And I'm still there. And so now I'm looking at the planetary systems and inside of that circle of technology along the front range from New Mexico to Colorado. Um, but I find what initially I thought was divisive between indigenous upbringing and native perspective and scientific knowledge was not divisive, in fact, but synergistic. And where that synergy is at the human scale, right? So I'll do my best to give that talk without going on long diatribes and falling into talking about Legos and stuff like that. But I'll leave it to my friends to keep me on track because I nerd out and talk too much like now. So I'm gonna be quiet. So I look forward to seeing my buddies with the wolf pack as always every single time we connect across the world. And also look forward to the listeners joining in with the wolf pack and joining the wolf pack with us. And bring your comments and conversations, and maybe we could have some back and forth dialogue sometime.
Yeah. Well, with that, I'll just say, Happy New Year, everyone. Here's to a great 2024.
Happy 2024, everyone.
Yeah, happy 2024.
Right. Wolfpack out.
Woof, woof. All right. Bye, guys.
Woo!
Bye.
Right.